All right, let's talk about one of the biggest challenges in enterprise AI today. How do you build one secure system that can serve hundreds of different clients at the same time? Well, today we're going to break down exactly how to build what I like to call a multi-tenant generative AI fortress right on Google Cloud. So, picture this. You're tasked with giving 100 different clients their very own private AI assistant, and you have to run them all on a single system. Now, each client has incredibly sensitive data. How do you guarantee, and I mean guarantee without a shadow of a doubt, that client A's confidential info will never, ever leak over to client B? That's the core problem we are solving today. To make this super clear, let's use a real-world example. Imagine a financial services company. They need an AI that can dig into confidential client portfolio data. The challenge here isn't just building one platform, it's about building a whole series of individual digital fortresses, one for each client, that all live together on that single platform. Okay, before we even think about the AI part, we have to start with the data itself. The absolute foundation, the bedrock of this whole thing is data isolation. You got to think of it like a bank vault. Each and every client gets their own completely sealed digital safe deposit box. No exceptions.
So here you can really see the difference between the easy way and, well, the right way. The risky shortcut is to just lump all the data into one big database and use a simple tenant_ID column to keep track. It seems easy, right? But a single bug in your code, just one little mistake, could expose one client's data to another, and that is an absolute compliance nightmare. The secure blueprint, on the other hand, demands true separation, a dedicated Google Cloud storage bucket and a dedicated vector index for every single tenant. It's not just a nice to have, it's totally non-negotiable.
I'm going to say this again because it is that important. This is the golden rule of this architecture. One tenant gets one storage bucket. One tenant gets one vector index. This one-to-one mapping is the foundation that makes real security even possible. Okay, so we've got our data in separate locked boxes. That's great. But now, how do we control who gets in? We need a really smart gatekeeper that knows how to give a user the key to their specific box, and only their box. The magic mechanism here is something called retrieval augmented generation, or you'll hear it called RAG. In a nutshell, RAG connects a big, general-purpose large language model, an LLM, to a specific private library of data. It basically tells the model, hey, before you answer this question, you must base your response using only the facts you find in this client's private library. In this secure flow, that tenant ID acts like the master key. So a user from tenant A asks a question, and their query gets stamped with tenant A. Then, at every single step of the process, the system uses that ID to fetch data only from tenant A's dedicated storage and index. This makes it physically impossible for the final response to contain data from any other client. It just can't happen.
And the bouncer at the door enforcing all of this? That's Google Cloud's Identity and Access Management, or IAM. We write super strict policies that say, this application, when it's working for tenant A, can only read from tenant A's resources. It's like a digital locksmith that makes it impossible to even try to pick the wrong lock.
We've secured the data itself, and we've secured the path to access it. Now it's time to zoom out and build that final outer wall, the network fortress. This is all about preventing data from ever leaving our secure bubble in the first place. Now, for industries with the most intense security and data residency rules, I'm talking finance, healthcare, the absolute gold standard is to go one step further. You create an entire separate Google Cloud project for each and every tenant. This gives you the ultimate level of control and segregation. The tool for the job here is VPC service controls. It sounds technical, but just think of it as building a virtual impenetrable wall around an entire project. And once that perimeter is up, you have total control over what data can come in and, more importantly, what data can go out. The power of this is just beautiful in its simplicity. Data stays in and threats stay out. This perimeter ensures that even if an attacker somehow stole a set of credentials, they couldn't just copy the data to some external server. Nope, the request would just get blocked by the wall. For meeting strict data residency laws, this is an absolute game changer.
So we've designed our entire fortress, from the data foundation all the way up to the network perimeter. Now let's pull it all together into a final pre-launch security checklist you can use.
So before you ship, you need to ask these critical questions. Is your data isolation absolute? Yes or no? Is your RAG pipeline totally locked down with tenant-aware IAM? Is that network perimeter active? Are you meeting all your data residency laws? Is every single access attempt being logged? And finally, has this whole system been validated against the necessary industry rules, like HIPAA for healthcare or GDPR for European data? A yes across the board here means you're in a really, really strong position. So let's just quickly recap the 3 pillars of our AI fortress. First, you have strict data isolation right at the storage level. Second, you have identity-aware access control built into your application. And third, you have a robust network perimeter. You combine these 3, and that's how you architect a truly secure multi-tenant system on GCP.
But here's a final thought for you. Your infrastructure is now a vault. It's locked down tight. But what happens if the attack isn't against the vault walls, but comes through the conversation itself? I'm talking about things like prompt injection, or trying to trick the model into revealing things it shouldn't. That is the next layer of this whole challenge, and it's absolutely where AI security is heading next.